In this video, we're going to finish coding our smart contract. As always, we'll start off from where we left off in the previous lesson, and to do that, we can git clone the repository with the appropriate branch. Don't forget to install the node dependencies. Let's go ahead and open the project directory. Let's bring up chatway.sol, which is our smart contract. Each message that a user sends essentially has three properties: the sender of the message, the content of the message, and the time and date that that message was sent. We can capture these properties using a struct, which I'll call message here. Note the different value types here. Address is a 20-byte Ethereum address, bytes32 is a 32-byte array, and uint is an unsigned integer of length 32 bytes. Each registered user will be given an inbox. Each inbox has four properties: the number of sent messages, the number of received messages, the actual sent messages, which is captured with a mapping, and the actual received messages, which is also captured by a mapping. Note that mappings are like hash tables, and here we're using them to store the messages by mapping them to the Ethereum address of each user. I'm going to define two more mappings. The first maps Ethereum addresses to the inbox struct and will hold the inboxes of all the users. The second maps Ethereum addresses to a Boolean, or true and false, and will indicate if a user is registered or not. Finally, I'm going to define two more variables. One is for a new inbox, and the other is for a new message, and these will be used in initialization. Now let's write our functions. The first function we're going to write will check the user registration. This will be a public function, and we'll use the view keyword because we're only going to check the variable. It will return a Boolean, and essentially it will return the value of the has registered mapping for the caller of that function. The user might receive a lot of messages, so we need to write a function that allows them to clear their inbox. We can do this by using the new inbox struct that we had defined previously, and by setting the user inboxes for the message sender equal to a new inbox. Now let's write a function that registers the user. The first thing we need to check is to make sure that the user isn't already registered. Next, we give the user a new inbox. We set the has registered to true for that user. Finally, we push that user's address into the registered users array of the contract properties. We're going to need a couple of more functions. We're obviously going to need a function to send a message. And this function will take the receiving address and the content, and it'll be a public function. We're also going to need a function to receive messages. Before I implement the send and receive message functions, I'm going to write a simple function that retrieves the number of sent and received messages for a particular user. Okay, now let's come back to the send message function. First, we're going to set the three properties of the new message struct using the input to the send message function. Notice I use the now keyword, which will give the current time and date. Now we need to update the sender's and receiver's inboxes. First, let's update the sender's inbox. Here, we simply copy the new message into the sender's inbox and update the number of messages he has sent. Now let's update the receiver's inbox. Here, we simply input the new message into the receiver's inbox and subsequently update the number of received messages by incrementing by one value. That's it for the send message function, so we can just return. Now let's implement the receive messages function. First, we get a copy of the receiver's inbox. And notice I use the storage keyword to make sure it's persistent. To make the programming a little bit easier, I'm going to assume that each user has a fixed maximum inbox size of 16. So to create a new message, I'm first going to initialize the sender, the content, and the timestamp. Notice that I'm using the memory keyword here, so it's not persistent, because I won't be needing these variables after I use them. Now I can use a simple for loop to retrieve all 16 messages inside of the user's inbox. Finally, we return the arrays of content, timestamp, and sender. So that's it for our smart contract for now. Let's save this file and exit to the console. Let's make sure our code didn't break anything. I'm going to run the start test RPC node in one terminal window, and in the other terminal window, I'm going to deploy to the developer using the deploy to dev script. Here you can see that test RPC again created 2 accounts. And now I'm going to compile and migrate the contract. Here we have the contract address and it was successful. So now I'm going to run our dev server. I'll do this in a different console. We can import the accounts by copy-pasting the private keys. Let's also open the Chrome console to make sure our code doesn't have any errors. It looks like we're okay. So this concludes this lesson. Again, if you had trouble following along, feel free to download the final version of the code by cloning the GitHub repository. I look forward to talking to you in the next lesson.